Hey student, welcome back. We're finishing up Unit 1, Limits and Continuity, and today we're going to look at special limits. And you may have seen these already. Sine x over x, the limit as x goes to 0 of sine x over x is something that teachers will include a little bit earlier on. I wanted to wait and include it with another topic because you kind of can skip both of these and still do really well in the AP test. But let's take a look. So the limit as x goes to 0 of sine x over x. And I graphed sine x in the blue and x in the green. If we plug in 0 using direct substitution, we would have sine of 0 over 0. Sine of 0 is 0. We have an indeterminate form, which does mean there's some sort of manipulation we can do. But it's really hard to see what that is. We can't factor sine x, we can't factor x, there's no conjugate to multiply by, there's no least common denominator that we need. So a good way for us to do this is by putting it into a table. So we've got the values of x, sine of x, and sine x over x. You can see these are very similar. The x values and the sine x values on both the left-hand side and the right-hand side. And so that means because these values are so similar, when we take one and divide it by the other, we get very close to 1. And so as we go towards 0, you'll see we just have more and more 9s. We're getting close, 0.99999, right? This is going towards 1. So the value of this limit is not 0 over 0. This is equal to 1. But the question is, what type of discontinuity do we have at x equals 0? We're undefined, but we do have a limit. So that means that we have a removable discontinuity. So we have a removable discontinuity or a hole at x equals 0. Okay, let's look at a couple variations of this because you're not likely to see this just as the limit as x goes to 0 of sine of x over x. You might see something like the first, which is the limit as x goes to 1 of sine of x minus 1 over x minus 1. And once again, we can't factor, we can't cancel, but you'll notice that this really is the same limit. We've just shifted it over 1. If we plug in 1, we would have sine of 0 over 0, indeterminate again. And we could solve with a table again. We would see that this is just 1. This limit is just 1. Next, we have the limit as x goes to 0 of sine x over 3x. So this is a slightly different limit, but because we can use the property of the constant times a function, we can take out the 1/3. We take out the 3 as a 1/3, and so that leaves us with sine x over x. We know this limit is 1, so 1/3 times 1 leaves us with 1/3. Okay. Finally, we have the limit as x goes to 0 of sine of 2x over x. Once again, if we plug in 0, we'll have the indeterminate 0 over 0. And this one is a little more tricky, right? Because we can't just take the 2 out. But if we look at our table, we notice that sine of 2x is actually going to be it's going to be a little bit larger than x. Right? We have 0.001 for x, 0.001999. And when we divide these two, these values get really close to 2. So this limit is 2. So whatever the value is on the inside, the coefficient of the x value, we take that and we divide it by the coefficient of the bottom. So we have the limit as x goes to 0. If this was, say, sine of ax over bx, I left off the x there, this would be equal to a over b.